This is Mario once again with MIA Microflight, and nothing to do with radio control models this time. I've been working on this project for a little bit, on and off here and there, and so this is an update to this build here. This is a pinball machine that I put together just out of the itch to do a pinball machine. I was itching to do one 2024, mid 2024, and something came up and I wasn't able to get around to do that. But this year, with a little more time, I've been working on this in my spare time. So this is an update. In my previous videos, you'll see another. I did another video of this machine working the bumpers and working some of the slingshots, I believe. But in this video, what I did is I wasn't happy with the bumpers that I was using. I've been using bumpers made from PVC tubing, which is sort of elastic, but not that much. I tried all kinds of rubber bands, and my last setup was using these O-rings. These are basically pieces of silicone tubing. This, I believe, is 3 millimeter in inside diameter with a 5 millimeter outside diameter, and I'm using a one of the PVC tubings that I was using as my bumpers. This part right here, the yellow part, as my coupler here, so that I can make my own elastic bands. So this was working okay. This is more an industrial material here that you buy, from places where they sell industrial parts and equipment, hardware. But I wasn't too happy even with this, so I went out and started looking for to see if I can buy some heavy-duty rubber bands. The pinball machines use, I believe, silicone O-rings that are in various sizes. But when you start getting in the size for a slingshot, your O-ring is going to be about maybe a 4-inch to a 4-inch diameter. So it starts getting a little expensive when you start getting up in those sizes. Small ones are not that expensive, but the larger ones are, it starts getting a little bit cost prohibitive, prohibiting if you're working with a budget. And I'm always working with budgets. Trying to even though I probably spend more without thinking on all these parts that I buy, solenoid switches, lights, it starts to rack up quite a bit of cost. I mean, I'm probably better off just buying a pinball machine, just a second-hand pinball machine, and just be done with it. But that's not so much fun as it is building one from scratch. For those of you that build things from scratch, you know the drill of doing it yourself. There's quite a bit of satisfaction when you get it to work the way you want it to work and the way you want it to look. So this is my pinball machine, and you can see some parts that I've been designing for and making 3D printed parts, additional parts for my. This is my ball guide, or this would be a track for the ball, and I have sort of established my angles already, just through a lot of trial and error, by seeing where the ball tends to go the most, so that it's a little more immersive, and any player can hit those marks with a little bit more ease and precision. This is a track system that I just did not too long ago. Again, once you can see the ramp there, and this one sits right there, and the other half sits right there. So I did this, and my angles. This actually was a little bit further out this way than this ramp is right here, and so I decided this is. It took a long time to print this, this track right here, and it's too bulky. I mean, I could have made it lighter, I suppose, but I was in a hurry to test a ramp and just see where the ball tends to go with the ramp in place. So I did away with that, and I started doing this instead. And this ramp is actually a remake of my smaller ramp, which uses same kind of clips, to clip these. This is nylon tubing, by the way. There are people that make the ramps out of brass tubing, not brass tubing, but brass rods or steel rods. To do that, but steel and brass, it's heavy, and it's and once you bend it, you can't unbend it without having a kink, or it's a lot harder to work with than just using nylon tubing. So this 1/8 nylon tubing that I mean, I have a lot of this stuff right here, so I decided to use that because that's what I had, and I decided to make these clips instead, which makes it a lot easier to manufacture a ramp any shape you want, because this is flexible material. The only thing with this is that you have to separate these clips at about, I'm separating them at about between 2 and 3 inches, 3 inches being the largest, longest distance between clip to clip. And that is just to make sure that these things don't open up, because the ball needs to ride, along this track. And so, as I was saying, the angle here, you can see my markings here, and this is my prototype board. I've been drilling here. I've been changing things around, relocating things, and so I don't care about wasting this, because I'm going to redo this on a CNC machine. This was done by hand, by the way, just to make it really quick. And so I'll be making it a little bit better. My track here is needs to be changed, because now I was using 1/2 inch to 5/8 inch diameter balls, and then I got these 3/4 balls, which engage better with the with the bumpers. I'm scoring pretty high there. And so so this is my setup here, and this video is about mainly the track, which is something new. I'm still working on the layout here. This is not finished right now. I'm printing some other ones with these clips are done in different heights. So this one is that is a little bit smaller than that, in 1/4 inch increments. So I started with one that has a 1/4 inch base, 1/4 inch height, and then I went to 1/2 inch, and then 3/4, then 1, and I went to 1.25 up to 1.5. But I don't think I'm going to be needing the 1.5s, because these are at 0.75 and they clear just fine the bottom play area. So that's my track here. Once I'm done with printing the rest of the clips, I need to print a little more so that I can get them a little closer to in spacing, so that it makes for a nice, a little more richer track. Right now this is a little flimsy because I have not too many clips here, and the separations are quite wide. But that's the idea with the track. And then I can these pieces are 36 inches in length, by the way. So very, very simple, very inexpensive, very lightweight. For those that have been following in my microflight, you'll remember how I used to make this nylon skids for the aftermarket parts upgrades for the tiny little micro helicopters. So I used to use a lot of this plastic, and just mold these into shapes. You can mold this into various shapes. I use these for I've used this for ribs, for my ultralights. I've used this material for a lot of things. I mean, the sky's the limit when it comes to creativity using materials. And so this is how my projects are done. There's a lot of creativity here. I don't like to duplicate exactly the same thing that the full-scale machines do. And so there's a lot of things that they may look the same, like these bumpers may look the same, but the triggering on these bumpers is my own triggering that I developed for just to simplify the switching mechanism that are typically as part of these bumpers. There's a stem that comes, a plastic stem that comes from the trigger point, and then that switch is a separate contact switch. I did away with all that, and I got my switch built into the center of the assembly there. I explained that in my other video. If you want to check that out, how I did that, check out that video that I explained all those things in detail. Okay, so that's the ramp. as I was saying, I'm still playing with the layout of this. What I want to do here is I want to make full use of the table here. I mean, there's a lot of area that can be used for more track. And so this is my entry point here, which is it's pretty consistent in line with this bumper, of course, here, which is more in line with this right here. So the ball will go here. The only thing here is that when the ball comes in, the way I designed this is so that it'll take these nylon pieces of tubing. So when it comes here, if the ball hits right here, it tends to bounce and it gets out of track. So what I'm doing here is just to simplify things and make things make life a little bit easier. So I'm building a sort of a gate here that's going to prevent the ball from falling from the sides as it hits this. So it'll prevent and it'll keep it in track, provided you can engage it with the center direction as the ball is hit in that direction. So I'm designing a sort of a gate here, just an additional part that's going to go around this, so that I don't have to redo this part again. I've done this part 2 times already, and as I typically say, you know, with all my designs, it typically takes me 3 tries. The first one is just to kind of get a feel for how the part looks, and then I make little changes. Second part is a refined prototype, and by the third part, you know, it's a finished product. So that's just the way that I like operating, and that's the way it works for me. Let me talk about these bumpers here for those that are interested in why this cool color here. You see these, and they're working extremely well. And I kind of knew that when I stumbled on these bands here. These are bands from the dollar store. They're called bungees. They're hair bungees. You can buy them in all kinds of colors. I bought them in colors and also in black material. And I was actually looking for rubber bands, like thick rubber bands at the dollar store, but they didn't have it. And you know, because when I go to the dollar store, I look at everything that they have there, depending on what I'm doing, what projects I'm doing. You know, I look for options. You know, so I went to the hair product section, and I figured, you know, maybe I can buy these. I was actually looking for these, which I found as well. So these are other bands, rubber bands, but they have a sort of a thread covering over them that's coiled over the rubber band that allows the material to stretch, and allows for the coloring of those rubber bands. But these are basically just rubber elastic bands. They should work just fine, but these are working extremely well because they have more elasticity into the material. And the material itself, is elastic, the covering. So, you know, these are and they're just the right size. You know, they come in colors. I got them in blue, purple, and there are some pink ones. They come with this badge here, so you can buy them in color, or you can buy them in black. So for the price that you're paying for these bands, look how many bands you get. And these stretch. I have another one here for my, and so they're working extremely much better than these black ones here. The commercial industrial material here, silicone tubing. So you know, that's the reason why I bought them. You know, because I can stretch these. I mean, that's about the max that you want to stretch the material. But you can take up some of this slack here and just bring it out like this, so that the material is a little bit looser on this end than the back, because the back doesn't need to be loose. And so the looser that is, the more springy it becomes. And it's working very, very nicely. So I think I'm going to keep these. And as you can see, you know, how the bounce rate is, you know, with these particular parts that I just mentioned, these elastic bands. Now this right here, this slingshot needs to be reworked, because I used a single contact switch, you know, those commercial contact switches, to build that one. And this I built first, and then I did this one with my own switches here. These are beryllium copper strips right here. just two little rectangular long pieces that are attached to two wires, you know, so when they touch each other. Let's see if I can zoom in on that part. You know, you can see how that works. And these could be a little bit closer here. I just opened them up because they were, oops, I just opened that too much. You can finagle with this and get it just enough to, so that it triggers with a little more. So this one has a very short spacing between these two. So I'm gonna have to adjust that so that the closer they are, the faster it triggers. But you can see how nice it's working. So I wanted to cover that and just share this information, you know, with people that may be watching my videos. You can use these bands. I mean, if you were to buy the silicone bands for the regular pinball machines, you know, you can spend easy on up to I think I saw one for $10 for one band, just one of the larger bands, $10. You know, I mean, I'm spending $1.25 and I have all the bands that I need here, and then some, you know, to do more bumpers. So the point with this machine is not to, like I said, replicate the bigger stuff. I don't. That's not my intention here. It's just to get creative so that I can come up with a working, functional, satisfying, you know, setup here. And this is providing that. On and off, on and off. I mean, I've spent quite a bit of time here on this machine. Already, I can't say the number of hours because you know, it's probably a good. I've probably spent a good month, solid 8 hours, working 8 hours a day. If I were to calculate it that way, but obviously I haven't been working every day on this for 8 hours, but on and off, on and off. So the amount of time that I've invested on this is about close to about a month. And there still needs to be, you know, some work done to the table. I need to connect the lights. I need to connect the sound processors and all these things that are going to be triggering this. Most of these machines, if you want if you want a little more realism, you're going to need to use some kind of a processor to process the ins and the outs. You know, the inputs being the solenoids, the switches. And the outputs being the lights or the sound that you might want to trigger, you know, when this is on and off. I'm still on the fence on the use of microprocessors here because I don't want to be coding things, and you know, that's a little more work, and I'd rather just do this sort of with some type of basic circuits, just electronic circuits with some kind of a logic built into the gates, a lot of and or NAND nor inverter type gates and amplifiers, you know, that I can trigger things and just make my own logic circuit that way, because this is not really complex the way I want this to work. What I want to have is, let me break it down in this way. Power supplies that I'm using here, but for the power system, beginning with the power, because that's number one. I am using right here just a 24 volt transformer, 500 milliamp hour. 500 milliamps rather, not milliamp hour, because that applies to batteries. 500 milliamp 24 volt transformer that I had, I don't know, from some toy or something, and I just have it plugged underneath the table, you know, and this the transformer is plugged to my wall here. So that's providing all the action here, and that's plenty. 500 milliamps is, you know, because no two things trigger at the same time. You know, even the bumpers, when they're bumping back and forth, you know, each one is consuming, I believe, 300 milliamps is what these are rated for. These are, by the way, bumpers, 24 volts, 300 milliamp hours is that solenoid rating, 5 Newton, and they're working just fine for this. I mean, other people have used 10 Newton, 20 Newton. I have some 20 Newton solenoids, but they're bulky. They're too big for this machine, so I decided not to use. I was going to use those for the flippers, but I actually like my mechanical flippers. I like to have that feel and control instead of just a button. I could change that in the future if I need to. That's not a big problem because I designed these, you know, for the solenoids underneath the table, so there's room there for the space for the solenoids. Actually, I had a couple solenoids activating this, and then I pulled those out. But So the solenoids are 5 Newton solenoid, 24 volt at 300 milliamp per hour. The higher the voltage, the better for triggering these things, because you have a much more efficient voltage on these solenoids. The full scale machines, I read that they operate on up to 70 volts, which is it's pretty high. That's why they're able to kick that ball with a lot more power. But this is not a full machine. This is 30 inches by 16. It's almost half the size of a full size machine. I believe full size machines are 20. What are they? 20. It's about maybe 24 by 50 some 52, 56 inches in length. This is 30 by 16. Um, uh, so the what I want to have here is, I was saying, the power system is that I'm using 24 volts for the solenoids. The LEDs can operate at 12 volts because they're the LEDs. I'm using LEDs with the resistors built in. They come from a company that I bought. I don't know. They sell all kinds of LEDs with the leads and the resistor already built in for 12 volts. So they're 12 volt LEDs with a voltage dropping resistor. I mean, the LEDs operate at a much lesser current and voltage, obviously, but the resistor does that conversion factors, and it allows you to use 12 volts. So all my LEDs are going to be 12 volts. So 12 volt power supply or 12 volt DC to DC converter operating from a much higher amperage power supply will do that trick. There's 5 volts for that is required for a lot of the logic circuitry that's going to be used here. I have been experimenting with some logic chips and counters and stuff like that. That I can, like I said, I'm going to do the logic myself, just using basic circuitry, so that I don't spend on processor. A processor would be a lot simpler and more compact and easier, but the programming is something that I haven't done programming in many years. Back in the 80s, I started with basic, learning basic, and learning some of the architecture and how that all that works. But I've never had to program things, really intense. And this is also not intense for somebody that has done that, but for somebody that hasn't done that, it's it can be overwhelming. The commands and burning the firmware into the processors and then having it communicate. So there's a lot of thought that needs to happen there. I don't want to complicate my life, and so I already have the circuits that I did with all the logic that I'm going to be using here. So if this gets triggered, light up this light, turn on this sound. It's real simple. The lights here can be just sequencers or LED chasers, just to operate the machine when it comes on. The lights come on and the sound also comes on at the same time. That eventually dies down after the machine gets enabled, gets established. And so the point here is that I'm going to be using some of these sounds. I bought this chip or this PC board that you can actually they came in a set of 4, I believe, for about $18. So they're about $5 a board, which is excellent price for a board that records MP3. It doesn't record it. You can load files, MP3 files, to it. I think it holds up to 256 files or something like that. But it can only trigger 8 sounds, whichever sounds you assign them is the board is designed to be assigned. Beginning with 0001 on up to 0008, and so I can have eight of those sounds activated by initialize the machine. Start the sound that typically initializes. You have the sounds of the pinball initializing. You hit a switch, you hit a bumper, for example, initializes that sound for the bumper, and so on and so forth. So it makes things a lot easier that way, because everything is already done. It's already recorded. It's already on that board, and all you have to do is just send a signal to the not even a signal. All you have to do is just hit a switch. You hit a switch for scoring. That also triggers the sound and also triggers the lights. So it's very simple from that perspective, without the use of microprocessors. And so that's the way I think I'm going to complete this table right here. And you can see already I've already had some lights. And my idea here with the lights was to mimic a little machine. It goes by the name of Rocker 3D pinball. It's a little table. It's about 9 by maybe 18 inches long. I showed that in my other video. I assembled that. It's a lot of fun machine for little kids, but this is a little more serious here. And so the way I started to analyze the way that they were triggering the sounds, a very simple way that they're doing that. They're using the same LEDs on the table to provide you the score, the visual score. So for example, this one, if this one is lit up, and you get 100, this means 100 points. You hit some sensor that is giving you that set up for 100 points, so that triggers that light. 200, 300, 400, 500, 600, 700, 800, 900, up to 1,000. So that's the way I think I'm going to set up my machine, so that I don't have to establish counters and additional circuitry. Very simple. Just use the lights and just put a number right next to it, to give you an idea of your score. Up to 1,000. Plenty for some very simple, fun, immersive feel. These other lights are these other lights that get triggered. You can see how that one is connected to these additional lights right here. And so I'm going to do the same thing. These green ones right here are nothing more than just covers. This is where I had my bumpers before. So because I was relocating things, I needed to cover this again so that the ball can travel smoothly. But basically, that's how this is going to be. So it's more, these lights actually need to be connected to 2 additional lights per bumper. The way I designed this table originally, you'll see a lot of holes here, but most of these holes have the mounting for the screws and 2 additional holes for the lights. So each one of these was meant to have 2 lights underneath. And when I redo this table on the CNC machine, I will have those sockets for the LEDs, 2 underneath here. So when, let's say, that bumper hits, it triggers these lights. I can also put a switch here, so when this gets triggered, it's almost similar to what's happening here, but instead of having a return slingshot kickback, it can turn on lights. So that's another way to do this. These are actually the covers, but I have them off so that I can see the action here and how this is working. That's how I'm going to be doing the lights. This has a sequence of lights here, that I was going to sequence this. This is as you're ready to engage the ball, you pull this back. This is going to have a circuit here. So when you pull back, all these lights it starts lighting up in sequence. Or when you hit the ball, these lights in sequence also. It's kind of like an indication of the ball traveling, or just to make it a little more spiffier. These islands here are also supposed to have LEDs here. They're supposed to be lit up, with LED lights. This right here, I'm going to redo. Actually, I started redoing this on the CAD program, so that I can have this way here. I'm going to need to change this because my ball, I went to 3/4 ball size, and so now it doesn't fit. So I need to redo these. In the new board that I'll do on the CNC machine, it'll be all cleaned up, obviously. But this is just going to be a single track here that's going to come here and just engage here. So this needs to grow a little bit further out, just to have more room so that the ball can travel directly. That way I don't need some mechanical troughs or risers or elevators, to bring the ball, from or guides to bring the ball back to this point right here. So this will be more in line with the with this VI here, or with this path, so the ball ends up right here. And one ball is plenty. I don't plan on stacking balls and guiding the balls. There's no need for that. So very simple. The simpler you keep this, I believe, for me at least, that's the way I intended this machine to do. So that is the one more time. I love that setup. I'm not changing that setup. It took me a little while to get it to do that. What it's doing there. So it's engaging quite nicely there. I may add some additional slingshot, an additional slingshot there with targets. That's the other thing I forgot to mention is I am going to have some targets and pop-up targets and just regular targets. Because of the size of this machine, I think that's this has to be done methodically so that I don't crowd with too many things here, so that yeah, this needs something happening here on this end here because this is kind of a little wimpy. The separation here, these two, this I think I'm going to change on the next on the CNC board that I'll be cutting, so that it engages better between those two and the bumper here. Maybe have another bumper right here with some kind of a slingshot, so that it really triggers that ball when it hits those areas here. I will be adding another track somewhere in here, and maybe just a loop like that little machine that I was talking about that has a vertical loop, which is kind of cool, that leads you into this track here and drops the ball. I'll have some switches and sensors also, some magnetic sensors that'll sense the ball travel or something similar. Mario, once again, thanks for watching.